السلام عليكم ورحمة الله وبركاته. This is our lecture in embryology cardiovascular module summer course about development and congenital anomalies of the heart, part 1. The objectives of this lecture are: explain the formation of the heart tube and the cardiac loop, discuss the development of the sinus venosus and its fate. First, let us discuss formation of heart tube. Okay. If you look to this diagram, you can see the embryonic disc, trilaminar embryonic disc. What is the first event of formation of heart? Is what's called angiogenic cell clusters. Angiogenic cell clusters, they are groups of cells that develop from the splanchnic layer of lateral plate mesoderm. If you remember, the lateral plate mesoderm divided into somatic layer and splanchnic layer. Somatic layer is the outer layer. By formation of intraembryonic thelum, divide it into somatic outer layer and splanchnic inner layer, which form the muscles of the gut and so on, also form the angiogenic cell clusters. These groups of cells or angiogenic cell clusters collect together to form what's called primitive blood vessels and blood islands. Okay, blood vessels. And then these blood vessels unite with each other to form what's called right and left endocardial heart tube. Which is the position of heart tube? It is in the most cephalic part of the embryonic disc and on each side. Okay, let us see these diagrams. This diagram is before folding in transverse direction. You remember in the first year you study the folding. The embryo fold in two directions, cephalocaudal direction and the transverse. Before folding in transverse direction, we can see the right and the left endocardial heart tubes. Okay, but after folding these heart tubes directed here in the midline, lie in the midline and fuse with each other. They fuse to form single median heart tube. Okay, also the embryo fold in cephalocaudal direction becomes C-shaped. You remember from the first year. As the head fold develop, endocardial heart tube and pericardial cavity rotate. It rotates on transverse axis about 180 degree. يعني لو انت عندك محور عرضي، الهارت تيوب دي بتلف حواليه 180 درجة. 180 درجة يعني هي جاية from منين؟ من الموست upper part of the embryo to lie in the thorax. 180 درجة. Look to this diagram please. This before rotation. Here you can see the heart tube and pericardial sac in the most cephalic part. But after rotation, here you can see the heart tube and pericardial sac rotate 180 degree, 180 degrees to lie in this cardiac swelling in the thorax. So the heart tube is the terminal position. It lies ventral to esophagus. Here you can see this is the esophagus developed from the foregut, lies in front of it, ventral to it. Number two, it lies below the developing mouth. Okay, here you can see this is the buccopharyngeal membrane, and below it lies the developing heart tube. And number three, it bulges in the dorsal surface of pericardial cavity. It bulges in the dorsal surface of pericardial. This is the pericardial cavity and folding. Now let us see the pericardial cavity. Here is the pericardial cavity around the heart tube. It bulges into its dorsal surface and suspended by what's called the dorsal mesocardium, mesentery of heart tube called the dorsal mesocardium. Okay? But after that, this dorsal mesocardium degenerates. If this degenerates, there is a space forming behind the heart tube, which is the transverse sinus of pericardium due to a degeneration or disappearance of dorsal mesocardium to transverse sinus of pericardium. You study it in the anatomy lecture. Now, what about the walls of the heart tube? In the adult heart, we have three layers or three walls. The inner layer is called endocardium. The middle layer, muscle, called the myocardium. And the outer layer is the visceral layer of serous pericardium called the epicardium. You will study this with Professor Dr. Amr in anatomy lecture. But what about the development? Till now, heart tube is formed only of one layer which is endocardium. This is endocardial heart tube. What's endocardial heart tube developed from? From splanchnic mesoderm. Okay, now look to a pericardial cavity. This is pericardial cavity. What is the layer between both? Between heart tube and pericardial cavity lies a layer called myoepicardial layer. Myoepicardial layer. What is this myoepicardial layer? Myoepicardial layer is formed of two layers. Inner layer will form the myocardium and the outer layer form the epicardium. Okay, myoepicardial layer is divided into two layers. You can see the different color. The light color, which is the inner, forms the myocardium, and the dark color, which is the outer, forms the epicardium. Now the heart tube developed from all these layers: the endocardium, myocardium, and the epicardium. Okay, now the three layers of heart tube: endocardium from splanchnic mesoderm, myocardium or cardiac muscle from myoepicardial layer. Also, it is splanchnic mesoderm, and lastly, epicardium or visceral layer of serous pericardium, also from myoepicardial layer. Thus, it is splanchnic mesoderm. Thus, all the heart tube develop from the splanchnic mesoderm. Okay, at first, heart tube is straight. You can see straight, formed of two tubes fused with each other to form a straight heart tube. It has two ends. Number one, cranial end, which is arterial, and caudal end or lower end, which is venous. Okay? The cranial end will be the arterial end, but the caudal end is the venous end. Now, due to the differential expansion of heart tube, what is the meaning of differential expansion? It's a parts developed, but not from the same direction or the same time. Some structures of it develop faster than others. This is called the differential growth. Leads to formation of five dilatation from above downwards. These five dilatations are: number one, what's called the truncus arteriosus, will form ascending aorta and the pulmonary trunk. Number two, bulbous cords will form the infundibulum of right ventricle and the vestibule of left ventricle. Number three, the primitive ventricle form the trabeculated part of right and left ventricles. Number four is the primitive atrium, divided into two atria. Number five, what's called sinus venosus, share in the formation of part of the atrium. Okay, these are the five dilatations, again from above downwards: truncus arteriosus, bulbous cords, ventricle, atrium, and sinus venosus. Now let us see the formation of cardiac loop. At first, the heart tube is straight. You can see it is straight from above downwards. But later on, it begins to bend, and become U-shaped. What is the cause of this bending? Number two, the bulbous cords and the ventricle elongate and they develop more rapidly than the rest of heart tube. Number two, and the second cause, is the arterial and venous end, the upper end and the lower end, are fixed to the pericardial cavity or the epicardium, and the remaining part of heart tube is free. Thus, when it begins to elongate, it bends. بالظبط يا ولاد لو شبهناها ببالون اللي هي الطويله اللونجيتيودنال بالون. If you pull air inside it while it lies in box، لو احنا حطينا البالونه دي في صندوق ونفخنا الهواء فيها، هل هي هتتنفخ ستريت؟ لا، هتلف حوالين نفسها تعمل الكاردياك. Thus, the upper part of heart tube descend downward and to the right and anteriorly, ventrally. And the lower part of the heart tube ascend upward and to the left and posteriorly or dorsally. Thus, it forms U-shaped heart tube. But later on, the atrium lies posterior to the ventricle here. Thus, it becomes S-shape. And later on, the atrium expand on both sides of bulbous cords. It expands, and this is the first event of its division. First, it expands and then divides into right and left. Okay, let us see this in exercise in our class. Which is the embryological origin of the epicardium? We said previously that the heart tube is formed of three layers: endocardium, myocardium, and epicardium, and all three layers develop from ectoderm, endoderm, somatic mesoderm, or splanchnic mesoderm. They develop from splanchnic mesoderm. Now let us see this in class ultra short question. Enumerate the causes of bending of heart tube to form a cardiac loop. These are two causes. Number one, bulbous cords and the ventricle elongate more rapidly than the rest of the tube. Number two, the arterial and venous ends of the heart tube are fixed by the epicardium. Now let us see the sinus venosus. What is the sinus venosus? It is the lowest dilatation. We have truncus arteriosus, bulbous cords, ventricle, atrium, and lastly sinus venosus. Sinus venosus is the last position. It lies behind the back of the primitive atrium and open into it. Okay, it developed from number one, small transverse part and right horn and left horn. Okay, these are the parts. Small transverse part open into the back of the right atrium, right horn and left horn. Now each horn enter in each horn three veins. Three veins enter in each horn. Number one, vitelline vein from the yolk sac. Okay. Number two, umbilical vein from placenta, right and left umbilical veins. Number three, what's called common cardinal vein. They drain the body wall of the embryo. Okay. Thus, there are three veins open into the horn of sinus venosus: vitelline vein from yolk sac, umbilical vein from placenta, and the common cardinal vein, which drains the body wall of the embryo. Okay, let us see what happened to this sinus venosus and its horns and the veins open into them. At first, you must know that the blood is shifted its direction inside the body of the embryo from left to right. Thus, all the structures go to the right side, enlarge. The structures go to the left side, become atrophied. Okay, let us see. First event is the entrance, the opening of sinus venosus shifted to the right. It opened into the back of the right atrium. Okay, the left umbilical vein and the left vitelline vein. This is left vitelline. This is left umbilical. Okay, they degenerate and lost its communication and disappeared at the fifth week. After that, left common cardinal vein also is obliterated at the 10th week في الأسبوع العاشر, but it is not complete obliteration. There is remaining portion of it and also remaining portion of left half of sinus venosus, the left horn. What happened to this remaining portion? Left sinus venosus and the left common cardinal vein with each other form the oblique vein on the back of the left atrium and the coronary sinus. They form the oblique vein of left atrium and the coronary sinus. What is the oblique vein of left atrium? It is a small vein, lies obliquely, called the oblique vein of Marshall, on the back of left atrium. Study it in the anatomy lecture. And the coronary sinus is the wide venous channel which drains the heart, developed from the left horn of sinus venosus. The right horn of sinus venosus enlarge and become absorbed into the back of right atrium to form its smooth posterior part. Also, you know from the anatomy lecture that the back of the right atrium is smooth. It developed from the sinus venosus. But the front, no, it is rough, formed of musculi pectinati, developed from the primitive atrium. Now let us see the opening. Here in this figure, I make coronal section of the atrium and remove the anterior wall. You see now the posterior wall, the entrance of sinus venosus, which is called sinoatrial orifice. This is guarded by right and left venous valves. Okay, they fuse with each other to form septum superium, الحاجز العلوي. Now, what is the end or fate of these valves? Number one, left venous valve and septum superium fuse with the developing interatrial septum. And now, what about right venous valve? It's a lower part to form two valves, valve of inferior vena cava and the valve of coronary sinus. This is the fate of right venous valve. Now, you can see this longitudinal band. This is crista terminalis. You study it in the anatomy. It is a longitudinal band between the rough part of the atrium and the smooth part. It developed from the right horn of sinus venosus. Now let us summarize the fate of sinus venosus. We will divide it into right part and left part. The right half, first right half. Right half, right horn forms the smooth part of right atrium and crista terminalis. Number two, the right common cardinal vein forms the lower part of superior vena cava. Number three, the opening of right vital line vein form opening of inferior vena cava. And number four, right umbilical vein disappear. Now, what about the lower part of right venous valve? It forms a valve of inferior vena cava and the valve of coronary sinus. This is summarization of the right side. What about left side? Left side, the left horn of sinus venosus forms the coronary sinus, and the left common cardinal vein forms the oblique vein of Marshall. With each other, they form oblique vein of Marshall and the coronary sinus. Left umbilical vein and left vital line vein, if you remember, lost communication with the atrium and disappear. The sinus and disappear. If the venous valve incorporated or become shared in the formation of interatrial septum. This is the fate of sinus venosus. Now let's see this question. What's the embryological origin of coronary sinus? Number one, left horn of sinus venosus, left umbilical vein, right horn of sinus venosus, right umbilical vein. Yes, the answer is left horn of sinus venosus because left umbilical vein degenerate and disappear. Right horn of sinus venosus, yes, this will absorb it into the back of the right atrium and form its smooth part. Right umbilical vein, it will disappear. Now let us look to this ultra short question. What is the fate of the veins open into right horn of sinus venosus? What are the veins open into right horn of sinus venosus? We have three veins. Right umbilical vein, right vital line vein, right common cardinal vein. What's the end of each one? Number one, right common cardinal vein forms the lower part of superior vena cava. Number two, opening of right vital line vein forms the opening of inferior vena cava. Number three, right umbilical vein disappear and lose communication with the sinus venosus. This is our resources and references. It will help you to study this part of our lecture. Thank you. We'll meet again in the next part. Thanks.